Math 97, Quiz 4 Topics. Simplifying a sum or difference of radical expressions, univariate. Our directions say, simplify, assume that the variable represents a positive real number. So our first example has 18x to the third radical x minus 2 radical x to the seventh. You notice that right now we cannot combine these two terms because the variables in them are not alike. And so what we want to do is simplify each term if possible so that they become like terms. In the first one, I cannot take the square root of x, and x doesn't break down any further. And so this one is pretty much simplified as far as it can go. But the second one, I noticed that x to the seventh would break into x to the sixth times x, and I can take the square root of x to the sixth, that would come out as x to the third, and so this now becomes 18x to the third root x minus 2. This x to the sixth comes out as an x to the third, because when we take the square root of an even power, it divides the power by 2. So this is x to the third, and then root x. That x is still under the radical. Now you notice that this x to the third root x is the same in both of those terms. And so since their variable parts are exactly the same, we are able to combine the coefficients by subtraction. So 18 minus 2 would be 16, and then we still have x to the third root x. And so that would be our final answer for the first one. In the second example, we have square root of 50z to the fifth plus 4z square root of 32z to the third. I cannot combine these at this point because what's underneath the radical is completely different. And so let's see if we can break down what's under here and take out as much as possible. 50 is not a perfect square, but I could break 50 down into 25 times 2, and I could break z to the fifth down into z to the fourth times z. And so now the square root of these parts, square root of 25 would be 5. I would leave the 2 under the radical. The square root of z to the fourth would be z squared, so I can bring that out. And then just leave the z underneath the radical. And so this is my first term, 5z squared root 2z. Let's take a look at the second one. 32 is not a perfect square, but I could rewrite it as 16 times 2, because 16 is a perfect square, and then break z to the third down into z squared z. I still have the 4z on the outside. And so now let's see what I can do with bringing these parts out from under the radical. Square root of 16 would be 4, so I can bring that out. I cannot take square root of 2, so I'll leave it under the radical. Square root of z squared would be z, and then I can't take the square root of z, so leave that under the radical. Okay, these are still not quite the same. Let's combine here. 4z times 4z would make 16z squared, and then root 2z. And now if I rewrite that first term, I can see that the z squared root 2z is the same in each of these terms, and so now I'm able to combine by adding the coefficients, the 5 and the 16, to make 21 z squared root 2z.